Hello, Ohio Superintendents Association. Oh, wait. Got it. Okay. Well, we'll go ahead and go. Thanks, Catherine, for that feedback. So we'll go ahead and go. Thanks for having us. I'm Greg Guy. I'm the owner of Air Force One. And on with me today is Austin and Brian Taylor, both team members of mine at Air Force One. And we're going to be speaking about indoor air quality and things that we can do as additional layers of defense against COVID-19 and other related viruses. So hopefully what we can do today and what we'll share with you is going to be impactful and helpful. And if you obviously would love any additional information, we're here to help. So with that, I'll pass it over to Austin and Brian. Thanks, guys.
Thanks, Greg.
Thanks, Greg.
And thanks, everybody, for joining today's session. I'm Austin. I will be kind of rolling through the presentation. Brian Taylor, Director of Automation and Energy Services, will assist on some of the technical aspects of what we discuss. This presentation in itself is kind of developed organically. Obviously, workplace health and safety and indoor air quality is at the forefront of all of our minds with the times. So we put together this presentation to kind of address some of the misinformation that's out there. So some of the topics we're going to discuss today are ventilation, system filters, routine system maintenance and cleanings, water treatment, improving indoor air quality, and hydroionization and PHI. So to start out, ventilation. And ventilation is essential to keeping people in the building and children safe and healthy. Adding fresh air accomplishes two primary goals. One, it controls building pressure, meaning that you don't have too much or too little in your spaces. But more importantly, it increases indoor air quality by diluting stale or polluted air. And I believe Brian would like to elaborate a little bit more in depth on the impacts of ventilation.
Yeah, and specifically for schools, of course, as Austin said, ventilation is key to having a healthy building. With that said, one of the first items that is removed and or minimized or completely disabled is your outdoor air economizers. I know many of you on here have went through House Bill project where it's energy based. The biggest thing to do is reduce outside air to help maintain your cost per square foot, and B, to maybe get a handle on some insulation that wasn't good. The other thing that happens is when you start having problems with equipment and the outdoor air damper possibly has failed, or you're having trouble heating or cooling, a lot of companies will go in, disable it, minimize it, or not allow it to open as far as it can, which, of course, decreases outside air and it causes building pressure problems. The reason ventilation is the topic is such a big deal is because the CDC, the state of Ohio, ASHRAE, and a couple other organizations have suggested not only going back to the ventilation that you're supposed to have based off of your original design documents, but also keeping that ventilation as far as you can to get as much outdoor air into the space as possible. That's a good idea, with the exception of a lot of times your equipment cannot handle the extra outdoor air, especially when you're on your really hot and humid days or when you're on your really cool days. So it starts causing trouble in your space. The other big one is it can make your operating costs double when it comes to the HVAC side of things. So it's very important to make sure ventilation is good, but not beyond the capabilities of your equipment. We'll go a little further into the ventilation side once we get to PHI, but I'll let Austin move on.
Thanks, Brian. And one set of housekeeping, feel free to ask questions in line to the topics so we can reference it in the proper context. So do not hesitate to ask us questions throughout this presentation. So system filters, and there's a lot of differing opinions and misinformation about system filters out there. So it's definitely something we want to address. As system filters keeps your systems operating efficiently and prevents contaminants from being introduced into your system. But simply switching to high efficiency filters is very dangerous. And we'll kind of elaborate on that here shortly. More specifically, mechanical equipment is designed for specific pressure drop associated with each class of filter. If you listen to the CDC in the state of Ohio, they've been recommending high MERV rated filters or even HEPA. Higher rated filters will reduce airflow and can cause significant damage. One thing to keep in mind, especially during these times, even if the filters don't appear dirty, make sure that they're routinely being replaced.
Right. So I'd like to add to that, Austin, specifically with some of the requirements set by the state of Ohio and the CDC. Most equipment is designed for MERV 8 filters. That's the standard. And moving to anything that has a higher filtering capability reduces airflow, as Austin said. Specifically MERV 13 and then HEPA. At that point in time, when you move to those filters, the pressure drops can sometimes be double to 3 times, and then as you move to HEPAs, it could be 4 or 5 times that of a MERV 8. Essentially, adding those filters will reduce airflow to a point where you're going to have heating and cooling problems in the space. It's actually going to raise energy costs because if your fan is on a VFD, the VFD is going to spin all the way up to try to maintain the airflow to the space. And secondly, filters really have no way of combating COVID. A, it's not airborne and it's not typically going back into the unit. B, the micron size of COVID-19, even on a drop of moisture, is still smaller than your MERV 13 or even the first line of defense in HEPAs. So is it a good idea to keep good and clean filters in your equipment? Absolutely, because it increases the life of your equipment and, of course, helps with your indoor air quality. Is it going to combat COVID-19? Not really. It's kind of like a placebo effect.
Thanks, Brian. And have any questions come in thus far?
No.
Okay, perfect.
No.
Moving on to the next slide. And we all know this is important, and that being routine system cleanings. It increases the equipment efficiency while reducing premature failure of equipment. Cleaning air ducts and coils will minimize allergens and reduce the spread of viruses and bacteria. Some additional recommendation that we would recommend your commercial HVAC provider does periodically is evaporator coil cleaning, cooling tower, and chemically treating your water loops. And we'll touch on the water loops here in the next slide. But really, the secondary benefit is it maintains the equipment efficiency, and it's going to extend the operating life and reduces catastrophic failures of your mechanical equipment.
Correct.
Do you have anything to add to that slide, Brian?
The only thing that I would add is, of course, cleaning your ducts and, of course, your coils makes a huge difference in how much energy you're going to use to move the same quantity of air, A. And then B, when you do have a buildup of dust, mold, mildew, and things of that nature, it starts to decrease your indoor air quality. It can cause other issues, especially if you have people with asthma or other respiratory illnesses such as that. Thank you.
And as I mentioned on the previous slide, one thing you do need to consider is water treatment. Your water systems protects your facility from Legionella or Legionnaire's disease and other waterborne pathogens. This is likely something that's overlooked in most people's regimen or plan, but we recommend that you establish, manage, and execute a plan to combat these contamination issues. And Brian, I know. Oh, sorry.
Go ahead.
I was going to say, I know water treatment is something that a lot of people kind of overlook, but could you talk about the impact that it has and what specific systems use water treatment?
Right. Well, I mean, from a mechanical standpoint, when you grow algae and one of the things you have to look at when you have, say, a cooling tower is it is a huge air scrubber. So as the water is falling through the tower and evaporating and cooling off, all the air that's pulled through there, and of course all the dust, mold, mildew, gets trapped in the water, goes into the water, and then builds up inside of your sumps, and also builds up inside of your pumps and all of your pipes inside. The other part that I think people really don't think about is as that water quality goes down, you still have steam coming off the tower, and people say, well, we don't have kids or we don't have people standing right by the tower, so why is it an issue? Where your tower sets, if it's upstream of prevailing wind, all that steam that's coming off the tower, whether you can see it or not based on dew point, goes over the school, and then all of your equipment that's bringing in outside air is now bringing that low quality, moisture-ridden, sometimes bacteria and mold-ridden air back into the space, which causes problems with your cooling coils and, of course, lowers IAQ inside the building. Very important to make sure that that's treated.
So now on to the meat of the presentation, and that's improving indoor air quality. Air purification products reduce pollutant levels. Adding PHI or photohydroionization, which we'll kind of elaborate on later in this presentation, is the only way to properly disinfect air streams. Indoor air plays a significant role in reducing the effects of harmful pathogens, such as bacteria, germs, fungi, viruses, and COVID-19. It also reduces odors and exposure to harmful VOCs. And then most importantly, or not most importantly, but another part to remember is that your economizers, which will proportion relief return of outdoor air and allow airflow to maintain healthy oxygen and CO2 levels within your facility.
So what I want to add to that is we just talked about the cooling towers and the fact that they can actually pollute the air that gets pushed back into the space. Before that, we talked about filters, which can be affected by that. And then we also talked about ventilation, which the last part of our slide is your economizers, which allow the air to come in, allow the air that's inside the space to be exhausted. That's more of a traditional system. Some of the newer schools and some of the newer buildings have outdoor air systems where you're doing some heat recovery. Those units still act the same way. You're just getting some recovery on it. So you still have the same situation, even if it's 100% outside air in that unit and it's going through an energy recovery wheel, it still has an impact on the indoor air quality.
Brian, have we received any questions from the previous slides?
I have not. And I guess what I'd like to add is because we can't hear you, please use the chat on the right side of the presentation. If you do have questions, comments, concerns, throw it up there. We are very, very happy to address those in line. Otherwise, we can wait till the end and revisit. Not a problem.
Thanks, Brian. So something we mentioned in the previous slide is photohydroionization or PHI. And this infographic kind of shows the cycle of how this works. And essentially, we install PHI on existing HVAC systems. And what it does is it recreates the outdoor air and eliminates 99% of pathogens that are airborne while disinfecting airstreams and all hard surfaces. This is very key, and we'll kind of touch on that in the next slide. So you probably ask yourself, how does it work? Well, PHI creates advanced oxidation processes, but simply put, it creates friendly oxidizers, meaning that these hydroperoxides circulate, out of your duct into the space and on hard surfaces and oxidizes the pollutant. Once it oxidizes the pollutant, it reverts back to H2O2 or hydrogen peroxide. Now, germicidal UV lights, and we'll kind of elaborate on this because I think there's some good points to some of the other technologies that are out there, has been used for decades in the medical industry to destroy germs, viruses, and bacteria. The one thing you need to be aware of is that UV light is only effective in reducing microorganisms that pass through the light rays. And what we know with COVID-19 is that it's not great at traveling. Therefore, it's highly unlikely, or it's not as likely to get back to your HVAC system. So that's where photohydroionization comes into play, or PHI, which can reduce microorganisms by 99.9% in the air and on all hard surfaces.
Yeah, I would like to explain a little bit deeper on the technology. So if we break photohydroionization down, you have photo, which is it uses a specific spectrum of UV light, and it shines it onto a metal catalyst. And what happens is the moisture in the air, as it flows over the catalyst, gets turned into H2O2, which is the hydrogen peroxide. A lot of people get a little bit confused. They think, okay, well, you're using UV to disinfect the airstream. In fact, UV strong enough to disinfect an airstream would have to consume so much energy, and it would have to be at a spectrum and at an energy level so high that it would destroy all the materials your air handlers built in. Typically, UV is used to disinfect coils. It's installed on the face of your cooling coil, which is a wet coil. The light shines on that coil and disinfects the coil surface. The air coming through that light moves at a rate that is too fast for it to be disinfected with the UV light rays. Granted, there's going to be some disinfection, but it's going to be lower than 30%. So with PHI, you're doing the exact opposite. You're still using UV at a significantly different range to turn moisture in your air into H2O2, which of course is an oxidizer. It goes into ducts, it goes into space, it actually comes back around into your unit. And of course, as Austin said, when hydrogen peroxide oxidizes and reacts with a protein-based material, it reverts back into oxygen. So not only are you removing some of the latent load and moisture that's coming through your building, but you're also turning it into the oxygen in your space. I know there was a part on one of the slides we didn't really touch on where PHI qualifies as green energy. This is very simply because it creates H2O2, oxidizes with pollutants and VOCs in your air and turns into oxygen. You can reduce outdoor air down to the minimum to maintain building pressure, and still keep very high indoor air quality, in fact, sometimes better than outdoors inside. So not only does it disinfect the space, it also allows for you to energy savings and get some ROI, which is hugely important.
Thanks, Brian. So I want to pull up some test results, speak about PHI. And in this lab test, they took a sample, installed a PHI unit. And within 6 hours, the H1N1 swine flu had an activation rate of 99%. And I think that's important because once that unit has been running continuously, it'll maintain that level. Brian, do you have anything to add to that one?
Yeah, so typically we get this question we have before. Okay, we do have a question here that I'd like to address before we get into this. So needlepoint bipolar ionization. It is a competing technology to PHI. It's just using ionized, positively and negatively charged ions to do something similar. I'm not going to say it doesn't work. What I'm going to say is it does not have the amount of time in the industry, nor does it have the medical backing when third-party testing when it comes to actually doing what it says it does. There's no doubt bipolar works and in some circumstances and in certain scenarios, but because PHI creates H2O2, which is something that's been used in the medical industry for 100 plus years, and we know that it's an oxidizer, we know what happens when it reacts, and we know that it targets very specific things, and that is protein-based material, which most viruses are. So needlepoint bipolar ionization is a competing technology. I don't feel that it provides nearly the amount of real data when it comes to actually performing in this space.
Thanks, Brian.
So let's get to the swine flu influenza slide here. As Austin said, once it's installed and operating in a facility, there is a dwell time between when it starts and once it's oxidized and actually got everything to 99% plus inactivation rate. People ask me, well, do we have to keep the air handlers running continuously? And the simple answer is no. As long as you're running when people are there, your inactivation rate is going to stay the same. So as long as your scheduling shuts the equipment off once people leave, it has the equipment on before people it will stay in the exact same state of 99+%.
And in a similar test, this kind of goes to the point that obviously a lot of us are trying to find ways to combat COVID-19, but there's additional benefits to air purification systems. And this particular test looks at mold, yeast, and bacteria. It takes a little bit longer at 48 hours, but has an inactivation rate of 97 plus. Brian, have we got any questions yet?
Other than the needlepoint bipolar ionization, no.
Okay, perfect. So this slide usually hits home because it speaks to what we all know, what we've heard, what the CDC is saying, what the state of Ohio is saying. Maintain social distancing at 6 feet, wear masks. This virus is a respiratory virus that's spread through coughing or sneezing. And what the manufacturer had done is they generated a test to kind of replicate the sneeze test. And what they found is that there was already oxidizers in the air and ready to kill the microbes at the source, to the point at within 3 feet, there was a 99% reduction. And this test was approved by the TSA and done for the TSA. So we know this technology does work. Does that mean that you can't wear a mask or social distance or, stop sanitizing? No, it does not. But this is just adding another protective layer to mitigate the spread of this virus.
Right. And something I think is very important here. The other question we get a lot is, well, how come we've never heard of this technology? Polarization has been around, I don't know, 5 to 10 years. It's kind of hitting mainstream recently. PHI has been around since 2000. It was patented in the 90s. It's been used exclusively in the healthcare and then the food packaging industries. And until COVID, nobody really thought about it. Nobody ever really wanted to spend the money for this type of technology. But now that we are, 2020 and COVID-19, it's come to the forefront.
Okay. So the next slide kind of talks about, what hydroperoxides exist in our outside environment. Because at the end of the day, with all the recommendations the CDC and the state of Ohio is giving, really we know that what's outside is good, and we want the outside air inside to naturally disinfect. So, why does the outside air naturally disinfect? And that's because the sun is a large UV source, and it interacts with naturally occurring metals in our atmosphere to create these hydroperoxides. That's why when you walk outside, the air just feels fresh and clean, and that's why there's not as much red tape with outdoor events. So, an indoor air has no hydroperoxides present, so the pollutants get to build up. And really, what we're trying to do with photohydroionization and increased ventilation is to get that fresh air indoors.
Yep. I don't have anything to add to that.
Well, with that said, that's generally the slides. We try to keep it about a half hour, 15 minutes for questions. So if anybody has anything as it relates to indoor air quality, things that come up, things that you're doing, questions you may have, please feel free to ask us right now.
Yeah, and while we're waiting for some questions to come in, so we do have somebody ask what it typically costs.
Mm-hmm.
I can tell you that it's equal to or slightly less than bipolar at this point in time. So to give a general budget, because it's very specific to the application. When you're talking about a small package unit that you might have on one of your smaller buildings, or a lot of schools have been built where, although you have a large central plant and chillers and boilers and VAVs and air handlers for your classrooms and the bulk of your building, your gymnasium and possibly your administration area have packaged equipment. So with that being said, the packaged equipment's anywhere from $1,500 to $2,000 per piece of equipment, up to roughly $6,000. And at that point in time, we're talking about 100,000 CFM unit, which is extremely large and probably nothing we're ever going to find at a school. That being said, the installation and power requirements are the same no matter how big the equipment is. The cost difference really comes down to the PHI equipment, how large it is based on what it's serving. So the other question we usually get in regards to that, which ties into cost, is, hey, we have, say we got a variable refrigerant system or a VRF, or we have heat pumps, and none of the heat pumps bring outdoor air in, and each classroom has one, or we have VAVs and each classroom has one. That would get really expensive. But we don't install it on each individual piece of equipment. We actually install it on the dedicated outdoor air system or the air handler that's serving those pieces of equipment, and that distributes it down to the individual piece of equipment, then the individual pieces of equipment distributed throughout the building. So there's definitely a scale factor that once it gets large enough, the cost doesn't keep going up, and pricing on a per ton basis is really tough. So hope that helps. We do have another question. Could you please describe where the equipment would actually go?
Perfect.
In our overall system or per classroom? Okay, so I kind of answered that one with the last one. If you have a VAV system, the air handler serving those VAVs, you would have one device installed on the supply duct downstream of the air handler, but upstream of all the VAVs. Likewise, if you had a dedicated outdoor air system with heat recovery, it would be installed downstream of that in the supply duct, but upstream of the heat pumps or VRF system which would distribute that.
And one thing to add, which we didn't touch on, is these units are, like Brian said, installed on the supply side of your HVAC equipment. We typically interlock those with the fan. So if the unit's running, the PHI system's running, and vice versa. If the system's not running, PHI is not running. And really, the energy draw for these units are essentially the same as a light fixture. So we're really not talking about a huge add, and in fact, we should actually lessen your utility spend.
Yeah, and in all honesty, the largest piece of equipment, which is good for about 100,000 CFM, is it draws about 1.44 amps. So it can actually be connected to, and I know this is getting a little bit into the weeds for some of you, it can actually be connected into the existing electrical or control power on the unit, with no need to add a breaker, run power from a panel source or anything of that nature. So it can really be installed in place with existing equipment and power, and very, very little impact to the rest of your systems. One thing I would like to touch on, I'm sure some of you are dealing with older buildings where you have some natural ventilation, no makeup air, and you're dealing with univents. I know those are still fairly prevalent. In that situation, we have a Univent specific unit. It's a cost that would go on each individual Univent and achieve the same thing, albeit at the end of the day, sometimes it's at a little bit higher cost because you end up having more labor and a little bit more, even though the price of the equipment's lower because it's on a smaller device, you have it scales up because of the quantity. I'm going to say 15 to 20% higher than if you have a more modern school. When I say modern, something that's been built in the last 20 to 30 years.
Well, Brian, any more questions coming in?
I do not see any more questions. I hope we answered questions and didn't create more. I know there's a lot of, as we started this presentation off, there's a lot of information out there, whether it be filters, whether it be outdoor air, whether it be, bipolar ionization, whether it be UV light treatment. And we know there's a lot of people out there trying to sell some of these things and take advantage. And I hate to say it that way. Our goal is to just try to clear the air, make sure you understand the technologies that are out there, how they can benefit you, how they can actually cost you significantly more money down the road. And to kind of summarize our presentation, ventilation is key. Filters are key, but filters should not be installed that are beyond what the original equipment was installed with. If you do go with a PHI or a bipolar, whoever's installing or doing this work for you really should be talking to you about reducing outdoor air, maybe getting an air balance or putting in CO2 demand ventilation. That can actually reduce your outdoor air, put in a PHI. The PHI pays for itself sometimes in less than a couple of months. And then you're actually saving money rather than spending money and not really doing anything. So it's very important to make sure all those pieces are there.
Thanks, Brian, and thanks everybody for taking the time today. Feel free to reach out to us if you have any questions. And again, just thank you so much to BASA for having Air Force One put on this session for everybody. Have a great day.
Yeah, and also, let me ask one question. We do have some very good third-party documentation on lots of different viruses, mold, mildews, and so forth from the CDC, from a bunch of universities throughout the country, and the federal government. It really gives you good perspective on how well this equipment works and what you should expect from it. If we can find a way to get that distributed out, we will do that.
Perfect. Well, thanks again, everybody.